In the previous quick start video, we've seen one of the methods that you can load data and a model into the NPU train function. But what happens if we are not providing that dataset, or that dataset is not on your dashboard? Let's look at it with a very simple example. I'm going to use Torch to download the fashion MNIST. So let's start. First of all, we're going to do all the imports. So let's import Torch. We're also going to be importing the Torch Vision dataset, and then just a couple of more things that we're going to need. And then we import the NPU, and remember to go into your dashboard, check what is your token, and then paste it there. Cool. Now that all the imports are ready, let's create a folder to save the dataset. Now that the path and the folder has been created, let's now get the actual dataset. So as I was mentioning before, I'm going to get the fashion MNIST from the Torch Vision package. And just to be explicit, I'm going to have it as train dataset and validation dataset, but both are actually coming from the same place. And now that we have all the datasets, let's now split X and Y for both training and validation. So the dataset comes actually with the number of samples and then height and width, but for the NPU API we need to have defined the number of samples, then the channels, then the height and the width. So we're going to unsqueeze this data. We're going to also transform it to NumPy so that it's going to be able to be processed by the training function. And then we're going to section part of this dataset, and we're going to select the first 40,000 samples, which is going to be part of our training dataset. And we're going to do the same for the validation, but instead of selecting the first 40K, we're going to go from the 40,000 samples to the end, which is I think 60K. Awesome. So yeah, now we have 40K samples for our training dataset and 20K samples for our validation. We're just going to tidy it up all together into train data and val data variables. So what I just show you, we are using Torch Vision dataset, but honestly, you could be using any of your dataset as long as you do process it into a NumPy array. That's really it. That's all the pre-processing that you need to have. So it needs to be in a NumPy array. Okay, now let's build a model. So we're gonna do a couple of convolutional layers, and then fully connected layer. Right. So something important is a difference with what you may have been used to in PyTorch is that you need to change, instead of calling super, you're gonna have to call NN model on the initialization. Besides that, then there's no changes into your model. And then it can be easily compiled by the NPU. Right, so for the first convolutional, we're going to build it using sequential. So we're going to put with one channel, because our image only has one channel. We're going to have 16 output channels for the kernels, and then a kernel of 3x3 with padding 1. We're going to then put some batch norm, 16 for the out channels, then the relu activation, and then max pool. For the second sequential layer, we're gonna also have convolution, batch norm, relu, and max pool. For our fully connected layer, since I don't know how many features are being fed in, I'm gonna, instead of manually calculating it, I'm just gonna build the forward path and then print the shape. So I'm just gonna put the layer 1, the layer 2, then flatten it so that I get the batch size, but then all the rest of the dimensions flattened. And I will initialize the model and put a random sample simulating the fashion MNIST. So now we can run a forward pass with our model and see what is the output shape. And we see that it corresponds to 1152, so I can just put that into the input features of my fully connected layer, and that's it. Then I will have built my PyTorch model. Alright, so now that we've already built a model and a dataset, we're ready to train our model. So we're going to first compile it, we're going to put the input shape, and then we're going to pass this compiled model into our train function. We're also going to use the training and validation data that we prepared before. We're going to use our cross entropy loss, the optimizer. We're going to set for this one 0.002 learning rate, batch size of 200, and we're going to go through the entire dataset 5 times. So that's going to be 5 times through the 40k samples on our training data. So we can now hit run to a script, and this will allow through the API to send our dataset and model over to our cloud, and the API will select what is the best hardware to run your model. See as well from our terminal what is the status. So now training has started, so we can go through to this URL and we can see very nicely how the loss is lowering, and as the model is going through the entire dataset, the 40k samples 5 times. So we can see as well here on the tasks, on this task specifically, more information about it. We can see as well the model ID and as well as the dataset IDs. So we can use that instead of to create an entire model again from scratch or loading it as a file. You can reference directly the IDs, which simplifies the whole process even more. So very soon, once the task is finished, we're going to be able as well to see the whole accuracy, and if we're happy with these results, then as I was saying, we can just use the model ID. Otherwise, we can retrain it as well. There we go. So we can see the loss and now the accuracy. And that's it. As always, thanks for watching, and I'll see you in the next video.